I want you to write the following in that box. So inductive reasoning is reasoning that is based on patterns you observe. Okay? So we're looking at patterns. We're using our prior knowledge to look at patterns. Okay? Well, Mrs. Crowley has a whole bunch of calendars in her room. What do I know from people? What's the pattern of people in the past that I've known that usually have lots of calendars? It means they're probably organized. Okay? They like to write things down. So, looking at patterns, the first easiest pattern that we're going to introduce is number patterns, which you guys have seen these before in algebra. So, figure out what the pattern is, and then fill in the rest of the pattern for the next two terms. What's happening from 3 to 6 to 12 to 24? We're doubling it, or multiplying by 2, right? So the pattern is doubling, or multiplying by 2, same thing. So what would be the next number? 48, followed by 96. Good. Okay. So those will be the next two terms in the sequence. Now let's throw shapes into our lives. We did numbers. Now let's do shape patterns. Exiting. How many pieces of the pie should be in the next circle? 8. What's the pattern? What's happening? It's adding by 2 each time. Here I had 2 halves, here I had 4 quarters, here I had 6. So the next should be 8. So let's do the best as we can to make 8 slices. So make your 4 and then cut those all in half. How many slices should be in the next one? 10. So you can do that one. 10. That gives me 6. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Got it. Just keep dividing sections until you have 5 on the top, 5 on the bottom. Okay? So, patterns. We're looking for patterns. So when you look for a pattern, when you say whatever it is, Mrs. Crowley is organized, Sarah likes music, that's considered a conjecture. A conjecture is the statement that you make based off of using inductive reasoning. Okay? So for our definition of conjecture, please write a conclusion that is reached using inductive reasoning. Okay? So a conclusion that is reached. So if you are asked in your homework to write a conjecture, you're just kind of writing what your conclusion is. Okay? It's just a fancy word for writing whatever you think is happening. So we're going to make a conjecture for this next example about the sum of the first 30 odd numbers. Okay, well, think about your odd numbers. 1, 3, 5, 7, 9, right? So I want to look for a pattern. Could we sit here and do 1 plus 2, or 1 plus 3 plus 5 plus 7 plus 9 plus, I don't even know what the 30th odd number is. We could do that on our calculator. That would be fun. Would you want to do that? Maybe not. I wouldn't. So let's see if we can find a pattern. So let's first start with the first 2 odds. What are the first 2 odd numbers? 1 and 3. If I add 1 and 3 together, I get 4. Okay, well that was pretty simple. Let's do the first 3. 1 plus 3 plus 5 is going to be 9. All right, not too hard. Can we do the first 4? 1 plus 3 plus 5 plus 7. What I really like to do is just add 9 plus 7, so 16, good. All right, let's do the next 5. 1 plus 3 plus 5 plus 7 plus 9. 25. Does anybody see a pattern happening with my sums?
Square.
They're perfect squares, aren't they? 4 is a perfect square, 9 is a perfect square. Well, that's pretty cool. So what do you think the next one would be? 1 plus 3 plus 5 plus 7 plus 9 plus 11 is 36. Okay. So then I could technically count out to the 30th perfect square.
Oh, God.
That still would be a little bit complicated. Because right now I only have 1, 2, 3, 4, 5 of them. So let's see if we can figure out another pattern. Here I took the sum of the first 2, emphasizing the word 2, odd numbers, and I got 4. Here I took the sum of the first 3 and got 9. Here I had the first 4 and got 16. So Steph got it. You guys getting it back there? Here I had the first 5, ended up with 25. Now we got it? So what's the pattern? What would we do to find the first 30? Multiply it by itself, or square it, right? So the sum of the first 30 odd would be 30 times 30, or 30 squared, which is 900. Good. Isn't that crazy how it works? Okay. So looking at patterns. Before we get to counterexamples on the back